everyone. This is Santosh Srivatsav Sharma. So in the series of three-phase AC circuits, now this is the third session. In this session, we will discuss three-phase balanced source, and in the same session, we will discuss what is star connection and what is the relationship between line voltage and phase voltage, line current and phase current in a three-phase star type of connection. This is very important concept in this particular star type of system. I mean, it is very important to know what is the relationship between line voltage and phase voltage, line current and phase current in a three-phase star type of system. Actually, in a three-phase system, we have two important type of connections. One is star type of connection and the other one is delta type of connection. So, why we need to go for star type of connection and delta type of connection? Because, what is the necessity of going for star and delta type of connections? Because if you consider a three-phase source and a three-phase load, each three-phase source consists of two terminals. Obviously, two terminals are phase and neutral. Three-phase source means three voltages, three sources, three single sources forms a three-phase source. Of course, the voltage V1, V2, V3 between any two voltages, the phase angle difference is 120 degrees. But in general, if you consider three-phase source means three single sources and each source has phase terminal and neutral terminal. Similarly, three-phase load means three single loads L1, L2 and L3. And again, if you consider each load, again it has two terminals. One is phase terminal and the other one is neutral terminal. Now, to connect from a three-phase source to a three-phase load, we require number of wires. How many number of wires means we actually require here 6 number of wires to connect a three-phase source to a three-phase load. Here we can clearly see in this diagram there are three sources and there are three loads. To connect a three-phase source to a three-phase load, we require 1, 2, 3, 4, 5, 6 number of wires has been used to connect from a three-phase source to three-phase load for the power transfer. 6 number of wires is actually a very large number. It increases the complexity, increases the amount of copper used, which again increases cost of the system and it is not economical, and finally this is not feasible. So we have to design systems which reduces the number of wires for the interconnection of three-phase source to a three-phase load, and such type of systems available are star type of system and delta type of system. In star type of system and also in the delta type of system, we use 3 number of wires to interconnect, for the interconnection of three-phase source and three-phase load. In general, if you go in general, it actually requires 6 number of wires to connect a three-phase load to a three-phase load. As it increases the complexity and increases the amount of copper, increases the cost, so we have designed two type of important types of system. One is star system and delta system. Both the systems uses 3 wires. Of course, sometimes the star may be 3 wire system or it may be 4 wire system, but the number of wires has been reduced, which is efficient as well as economical. So this is the importance of star and delta type of systems. So now let us go in detail with the first type of system, and that is star type of system. So now, how to form a star connection, how to build a star system, and later we will see what is a balanced system. In this session we will see what is a balanced source. Now, either it is star type of system or it is delta type of system, we require 3 elements. So here I am considering 3 coils. Say this coil 1, starting terminal of coil 1, finishing terminal of coil 1. Second coil, this is second coil with the starting terminal S2, finishing terminal F2. And the third coil where S3 starting terminal and F3 is the finishing terminal. Now if you consider these three coils, by using these three coils, three set of windings are used in a three-phase system, and these three set of windings to be connected in star fashion. How to connect these three coils in star fashion? It is very simple. Either we connect all the starting terminals together, or either we connect all the starting terminals together, or we can connect all the finishing terminals together, and this forms a star type of system. The method is, we consider three coils, we can connect all the starting terminals together, or we can connect all the finishing terminals together, and such a type of system is named as star type of connection. And any number of phases, any number of windings can be used in star type of system. I mean, actually speaking, in polyphase type of system, we use the word star type of connection. If you consider three-phase system, we need to use Y connection, because these three coils can be arranged in the shape of inverted Y. You can see here, this is inverted Y shape, or we can reverse it. So the three coils can be arranged in the shape of Y or reverse Y. So star type of connection in three-phase system is named as Y connection, star connection or Y connection. Now this is the procedure to form a star type of system, and here we have considered a star type of system. And what is that star type of system? Whether it is a three-phase source or a three-phase load. The first question is, this is a three-phase star connection, and whether this is a three-phase source or three-phase load. Say here I have considered this three-phase star connection as three-phase source. I mean, these are the three set of windings. These three windings are the three windings of alternator, three-phase alternator. Now I have considered these three windings as alternator windings, and this is representing a three-phase source, and from this three-phase source we are actually getting the three-phase supply. We can also represent a three-phase source like three single sources connected in star format. This is the symbol of three-phase source. Now that represents three set of windings of alternator connected in star format. Now the question is, why do we use star type of connection for alternators? Because the main theme is, if you consider this star type of connection, we have two types of voltages. One is line voltage and the other one is phase voltage. So across each coil, less amount of voltage, the winding will be stressed with less amount of voltage. So we use alternators, three-phase alternators. We use it as star type of systems. We will discuss what is star type of connection, what is line voltage, what is phase voltage, what is line current, what is phase current, and at the end of this session we will be very clear that three-phase alternators are of star type of connection. It will be better. So now first let us define what is line voltage, what is phase voltage, what is line current, and what is phase current. Here we have two types of parameters, line parameters and phase parameters. So now what is line voltage? Line voltage is actually line to line voltage. Simply it is called as line voltage. What is line voltage? Voltage between any two lines. Here lines means live conductors. I mean, this is R set of Y, this is RY which carries current, this is YY which carries current, this is By, and this also carries current. Now there are 3 live wires here, and the 3 wires are RYB. What is RYB? RYB means in Indian electric system we use RYB, means colors, red color, yellow color, blue color as the live wires. This is the color coding which we use in Indian system. In Indian electric system, R represents red color, which is live wire, which carries current. Y means yellow colored wire, it is also a phase wire. B means blue color, and it also carries the current. And there are 3 phases, 3 live wires and 1 neutral wire. And this is neutral wire, dotted line represents the neutral wire. And here, what is neutral point? The point where the 3 set of windings meet is called neutral point. And at neutral point, in a balanced system, the voltage is 0 volts. And the sum of currents, even the sum of currents at neutral point is 0. And this is a balanced 3-phase source. Now, what is the meaning of 3-phase balanced source? And what are line phase voltages, what are line phase currents? Let us discuss in detail. First of all, what is line voltage? Voltage between any 2 live wires is line voltage. Voltage between or voltage across each coil is phase voltage. First let us write the line voltages. Here the voltage between R line and Y line is a line to line voltage. Voltage between Y line and B line is also a line voltage. Voltage between B line and R line. These are the 3 line to line voltages, are simply the line voltages. And now what are the phase voltages? Phase voltage means voltage across each coil. Voltage across first coil. What is the voltage across first coil? It is VRN, and that is defined as phase voltage VRN. Voltage across second coil is VYN. This is a phase voltage. Voltage across third coil is VBN, and that is a phase voltage. Here clearly we can see the difference. Voltage between any 2 live wires is line voltage. Voltage across each coil is phase voltage. There are 3 line voltages and there are 3 phase voltages. And from the connection diagram, we can clearly say line voltages are not same as phase voltages. Both are different. And next, what is line current? What is phase current? Line current is the current flowing through live wires. This is a live wire, and the current flowing through this live wire is IR, which is line current. Current flowing through Y live wire is IY, which is a line current. Current flowing through B live wire is a line current, and that is IB. The line currents are current flowing through live wires. What are the currents here? IR, IY and IB. Now what is phase current? Similar to the definition of phase voltage, what is phase current? Phase current is the current flowing through each coil. Current flowing through first coil is IR and it is phase current. Current flowing through second coil is IY and it is a phase current. Current flowing through third coil is phase current. Now if you observe this connection diagram, the current flowing through the coil, say for example the current flowing through the coil is IR, the same current enters into the line. Current flowing through the coil and current flowing through the live wire, both are same. Current flowing through the coil is phase current, which is same as the current flowing through the live wire, which is line current. From the connection diagram itself, we can say phase current is equal to line current. Phase currents are same as line currents. The phase currents are the current flowing through the coils. Line currents are current flowing through the live wires. From the connection diagram, we can clearly say current flowing through the coil, which is phase current, is the same current entering into the line. is the same current entering and flowing through the live wire. So that we can come to a conclusion that in a three-phase star type of system, line current is equal to phase current. From the connection diagram itself, we have derived the one relationship, and what is that? The relationship is line current is equal to phase current. Now these are the various parameters: line voltage, phase voltage, line current, phase current. Now we have already derived the relationship between line current and phase current from the connection diagram. So let us derive the relationship between line voltage and phase voltage. Now, while discussing line and phase voltages, there arises a concept, there arises a question: what about the magnitude of these three voltages? I mean, what are the values of these three voltages? What are the values of these three voltages? In a balanced source, in a three-phase balanced source, all the three voltages are equal in magnitude. Similarly, all the three line voltages are also equal in magnitude and displaced equally by 120 degrees. I am saying about phase voltages first. All the three phase voltages are equal in magnitude. Magnitude of three voltages is same, equal value, but displaced by 120 degrees. Three phase voltages are same in value but differing phase angle by 120 degrees. Phase angle between VRN and VYN is 120. VYN and VBN is 120. Similarly, phase angle between VBN and VRN is 120. Such a type of system is called three-phase balanced source. A three-phase balanced source consists of three line voltages or three-phase voltages. I mean, the three-phase voltages are same and phase angle between any two phase voltages is 120 degrees. Similarly, we can say the three line voltages are also same and phase angle between any two line voltages is 120 degrees. So now let us derive the relationship between line and phase parameters. I mean between line voltage and phase voltage. Now to derive the relationship, let us consider R to N to Y, this particular loop. I am considering this particular loop, or through the winding neutral point, through the winding Y and to the point Y. So I am applying KVL for this particular loop, and upon applying KVL we will get voltage across RY, which is a phasor. I am using a bar. VRY is equals to VRN plus VNY. VRY is equals to VRN plus VNY. VRY is equals to VRN plus VNY, which we can rewrite it as VRN plus of minus VYN. So VRY is a phasor which is the phasor sum of VRN bar and minus VYN bar. So now to derive the relationship between line voltage and phase voltages, VRN is actually a phase voltage, minus VYN is also a phase voltage, VRY is a line to line voltage. We need to consider the phasor diagram. Now I am drawing the phasor diagram. This is VRN, which is same as VYN. I mean length of VRN is equals to length of VYN, but VYN lags VRN by 120 degrees. Similarly, VBN lags by 240 degrees. I mean from VRN the total angle is 240 degrees. We can write the line voltages as phase voltages as VRN, VYN, VBN. These are the phase voltages. A balanced three-phase source means all the three voltages are equal in magnitude is equals to a common voltage V. If you take reference VRN at 0 degrees, VYN lags VRN by 120 degrees. VBN lags VRN by 240 degrees. So this is the phasor diagram. Now the phase angle between any two phasors is 120 degrees. This is the 120 degrees between VBN and VRN. Now we have to represent VRN minus VYN in this phasor diagram. VRN is already there in the phasor diagram. Now what is minus VYN? We have VYN here, but here it is minus VYN. To get minus VYN reverse vector, we will reverse the VYN vector. And here the angle is actually 120 degrees. Now this VYN is reversed. VYN is reversed, which becomes minus VYN. And here we have VRN and minus VYN. If we add minus VYN to VRN, as per this equation, we will get VRY. Now we use parallelogram law of vector addition. We use parallelogram law of vector addition and we will solve this particular problem. These two are adjacent sides of this parallelogram. So the sum of adjacent sides of the parallelogram is actually diagonal. And this diagonal is sum of adjacent sides. The adjacent sides are VRN and minus VYN. If you add VRN and minus VYN, we will get VRY. And what is this diagonal? This diagonal is now VRY. And now this angle, when we draw VYN as reverse vector, this overall angle 120 degrees gets bisected into 60 and 60. And when we draw the diagonal, this overall 60 degrees gets bisected into 30 degrees and 30 degrees by this diagonal VRY. And here, from this diagram, we can say VRY, which is actually line voltage, VRN, which is actually phase voltage. The angle between line and phase voltages is 30 degrees. And we can say this 30 degrees is in anti-clockwise direction, which means that line voltage leads the phase voltage by 30 degrees. So here I am writing line voltage leads phase voltage by 30 degrees. This is one of the important relationships between line voltage and phase voltage. So now to get the magnitude relationship, this whole length is VRY. We will project a perpendicular bisector. We will project a perpendicular 90 degrees. Bisector means VRN is the whole length, which is bisected into VRY by 2 and VRY by 2. Now this angle is 30 degrees. We will consider the points as OA. OA means VRN and OB means VRY by 2. And let us consider this triangle. And what is this? This is a right angle triangle where this is point B. This triangle is shifted like this, so that this point is A and this is point O, and here it is 30 degrees, here it is 90 degrees. Now what is OA? OA is VRN, which is hypotenuse. What is OB? OB is VRY by 2. Now from this triangle, we need relationship between phase voltage and line voltage, means hypotenuse and adjacent side. Relationship is given by cos theta, and cos 30 degrees is from this right angle triangle is adjacent side. What is adjacent side? VRY by 2 by hypotenuse. What is hypotenuse? VRN. Now cos 30 degrees is equals to VRY by 2 by VRN, which implies root 3 by 2 is equals to VL by 2 V phase. 2 and 2 gets cancelled, and from this we can say VL is equals to root 3 times V phase. Here I am writing the relationship. VL is equals to root 3 times V phase. VL is equals to root 3 times the V phase voltage, and also here we have line voltage leads the phase voltage by 30 degrees, which means we can combine these two relations, and here we can finalize it as line voltage is equals to root 3 times phase voltage and leads the phase voltage by 30 degrees. And this is the overall relationship between line voltage and phase voltage. And the relationship between line current and phase current is IL is equals to I phase. So this is regarding star type of system. And we have derived the relationship between line voltage and phase voltage, line current and phase current. Thank you. In the next session we will discuss about delta type of system.